Hello everyone, this is Sam from HiPy. We're here with another guide on how to import data using pandas into Python. What's important for this tutorial is that you have the data that you're using inside the same folder as the IPython notebook that you have open, otherwise it won't work. You'll have to use some funky things like specify the path that you want to use and whatever, and we don't really want to do that because we're lazy. So just keep it in the same folder that you're using. It's helpful to organize all of your work into folders as well anyway, so I'd really suggest doing that. But importantly, number one error that comes up is I can't find the file, and it's because 9 times out of 10 we don't have the file in the same folder as the notebook. So once you've done that, we're going to import the modules that we need, so numpy as np and pandas as import pandas as pd, shift enter, and then the two main functions we're going to be looking at today is the, let me just type these variable names in first. We have the pd.read_csv, and then it takes as an argument in the file name with the extension, and then the other one we're going to be looking at is pd.readxl. So write this in, and we have importing data.e, no it's not e is it, it's xlsx, there we go. So if we press shift enter here, we can look at the heads of each of these files. We have df1.head, df2.head. We can see that df1 is just the numbers 1 through, or 0 through 15 in a 4x4 grid, and df2 is just a kind of 0 and 1 lattice. So that's quite helpful. But what's even more helpful is if we pass a URL as the argument to read CSV or read Excel, that is like the download link to a file, we can actually just get the file in straight away. So if we have pd.read_csv, and then we open the brackets, here I have a nice URL of the local authority codes and some data to do with that. So if we pass this URL in, that's the download link. If I pasted this link into my address bar, it will just start downloading the file. So make sure you've got the right link, otherwise it won't work. And then if we look at the head of df3, we will get all of this data. So we can see here the main things that we're going to be interested in is the official name, the name, and the local authority English kind of 3-letter key. So what we're going to be doing from here is we are going to be analyzing what is going on in this column here. We're going to be looking at the first letter of each code and see if there's any kind of like analysis we can do on it. Is there any surprising data that we might get out of it? So that might seem a little bit boring for now, but it's mainly to get our feet wet in the area of data analysis and kind of like explore what's going on. So what we want to be doing, just to make our everything run faster, is just create a new data frame or update the data frame with the local authority English abbreviation in. So we can see here I just tab auto completed it, and then if we press shift into here and then we go head dot no, it's not head, it's df3.head, we will see we now just have a series with all of these in. Now from here we can just very quickly get the first letter out of each of these. You could do this a number of ways. Personally, I would do it using a lambda expression, but since we haven't done those yet, I'm going to create a quick function definition here called get first letter. I'm just going to input a string, and then that's just going to be sorry, let's get this out the right way. Let's type things correctly, and let me scroll down. We're just going to be return the first element of the string. So we have string 0 here. So what this is going to do is it's going to take in any string and then just return the first letter of the string. So we then are going to create a new data frame called counts, and all it's going to do is going to be the I'm going to type this first and we will see what's going on. So what this is what's happening here is it's taking the data frame df3 and it is applying the get first letter function to every single element in that data frame. So what it's going to be doing here is it's just going to be taking all of these first letters and then outputting another data frame with all those first letters in. And then from here what we can do is we can just say counts, let me click the right place, counts is equal to counts.value_counts. And what's important here is counts here is the name of the actual data frame. Counts here, value_counts is actually the name of the function. So that's a little bit confusing here, but I've just called it counts because it is the counts of our of our letters, and then if we just type in counts, in fact we'll print counts, we'll see here that we have 52 S's, 38 W's, 35 B's, 30 C's, and so on and so on. So this is a little bit interesting because we'd be expecting letters like E and A, maybe the kind of really common letters to be at the top of the list, but we actually see still common letters like S, but also kind of some uncommon letters like W and N really hit far up that list. And what we can do now is, just to be a little bit cheeky, we can use Panda's inbuilt visualization to plot what's going on here. So counts.plot.bar and then plt.show, we will get the bar plot of the distribution. We don't have plt because we haven't imported matplotlib, so let's quickly do that. Import matplotlib.pyplot as plt, and we'll see now we have a nice graph of what's going on. And if we want to make this a little bit better, we can go fig size equals 10.7, and we now get a nice big graph of what's happening. So we can see here S is the most common by quite a long while, but we also have letters like A here, which we'd expect to be far up this graph to be quite low down. So my challenge to you is why is this the case? Why can we think of any idea of why S and W, N, and as another hint E are so far up the list, whereas other kind of quite common letters like T is quite common, A is quite common, E is quite common, are further down relatively the list? And if you get an idea of what's going on, I want you to come back up here to the actual main data frame and import the data frame again, and then look at the official names here and kind of create a new data frame with just the official names and test out any ideas that you might have about it. So for example, one idea would be like, maybe if C comes up quite a lot, I would, which it does, I would take the official names and then look at how many official names start with the string city, so you can have some kind of a little bit of fun with the analysis there. And then the mini projects I've got set up for this guide is basically a very similar thing. I want you to just go to another government file, import it as a CSV, and then just find out how much money the Department of Education spent in February 2017, I believe that is, yeah. And it's just in costs of 25,000 or over, so you're not going to get a particularly precise figure, but it's always fun to get kind of like the kind of a general idea, and then try and break down the expense by type or supplier just to see what's going on. So that's kind of like a bit of an open-ended exercise for you to do. You kind of get whatever you want out of it. If you've got a great idea of what's going on here, it's fine. You don't have to. Well, you don't have to do anything like that anyway. But it's just kind of like a little project that you can do in your spare time if you really want to. So next time I'm going to be looking at how to import the data off the web in a more general format using some other libraries. But for now, that's it. So I hope you've had fun doing this, and I'll see you then.